Oh, hi again. I wanted to do a little. I have theories about electricity and lightning and how they work, and I don't really like sharing it online because I don't get much feedback. I mean, the idea of sharing something is that you get into a conversation and you learn about other people, and I don't just like feeling like I'm feeding the sharks some feeding frenzy, and off they go, and they're just going to eat it all, and I won't get anything back. That's what it feels like. The internet's like a shark feeding tank. Sometimes. Um, yeah, but I've been sitting around here eating too much food. Look at this belly, would you? Packets of chips and oh dear, soft drink. Oh, look at these things. Calamari. I said, oh yeah, a bit of batter. I forgot the one I really would like is just a thin little bit of butter. But look at that. I'm not having a go at them. It's just that's huge. I better eat it. It's cold. Anyway, I'll just have a drink. I'm kind of healing up my feet at the moment, so I've got to keep feeding the energy in. If I exercise, my feet will get damaged again. I'll just have weight, because the weight's on so you can heal your feet, and it'll slowly go away. You gotta do movement, but I wouldn't go running, with sore feet. Probably battered fried food's not the best, but I sort of have a theory that what you consume, you store what you need anyway. You're sort of we're all doing the right thing. These big fat people, the ones that can't get off their couches, it's kind of like they're continually hurting themselves in their hearts, and they're trying to heal up, but consuming too much food at the same time. And what happens is they get depressed in the brain, and that never heals up unless you have a positive attitude. You got to have something positive to almost lift you out of that, because if your brain's not functioning right, you just keep eating and not exercising at all, you're never going to heal up. Because healing isn't just sitting and healing. You've got to move as well to burn the calories to then heal your feet, or your body, or your heart, or your mind. So it's a process of healing when you're overweight. It's not so much losing weight, you're just using that energy in your body to heal what's damaged. And you'll store up enough energy to do that, but you also need energy to burn energy. So you need a bit of food to burn the fat. It's a funny process, but I'm slowly getting there without getting the skin hanging off. But yeah, I have this interesting idea about electricity that when someone suffers a shock from a high voltage, it's almost like the voltage tells. This is just a mathematical view of it, so it's not reality, really. It's mathematics. It's a layer. It's like language, expression. It's like doing this with my hand, my fingernails. What am I doing? Unless I tell you, you probably don't know, do you? So really, this is reality. And then this is a layer of meaning. My hand is an ostrich. Look, it has feathers. Without me saying that, you wouldn't really know, would you? Mathematics is a bit the same. It's like saying, you know, um, this punch is made of steel that's fabricated to a certain length and pressure, and so you can do this and that won't break, and under certain pascals or something. Make up all these words and names and phrases named after people. I think it was Louis Pascal or something. They named it after the pressure. And so really, that's all made up as well. It's a language to explain what this is. We know sort of what it is, but unless I tell you, you might not know what that does, will you? So I'll say, apply this much pressure, put a punch in there, and put it on your fabric and do that. Like twice until it's done, or something, So you don't understand mathematics is a layer of meaning which can be changed and obscured and manipulated and twisted, and in the end it can mean nothing, and you just end up with what is, what's there. And what is there can be a mystery too, as there's layers of energy, layers of matter, constructs, polarities, whatever we understand, that's kind of mathematics as well. So when we talk about electricity, we're saying, 12 volts will travel through a circuit, and for it to work, it has to equal at the other end. Once it's gone through the circuit, everything has to equal zero by the time it gets to the other end. Otherwise, there'll be no current, because the current has to be discharged. So for that to work, that amount of energy to discharge at that certain time and rate, you have to have certain resistors, capacitors, diodes, whatever, LEDs or devices or components on there to burn that bit of energy. So by the time it gets to the end, it's zero. So in the same way, a human being will get struck by electric charge and go through its body and the resistance, and that will, if it's the right resistance, if your body can't really take that charge and burns away, it'll end up equaling zero at the end, and your heart will hear, oh, zero, oh, I'm dead. So it will switch off. If it's gone through your heart, it receives that message that it's an equal amount of current going through your body to switch you off, because you burnt the energy. So now let's switch off. It'll switch off your heartbeat. Oh, excuse me, sorry. So you'll die, but it doesn't mean electricity is nothing. It's not empty. It's the opposite, really. But it's hard to understand how electricity works, because all it is really a signal it sends from one end to the other to tell matter that some work's been done. So it's saying the work's been done. If it's zero, you can switch off. So once that bit of work gets done, the light flickers and then goes off. That's it until the next pulse or whatever, or the next time you switch it on, or the next bit of current, or that can happen every second or every nanosecond or whatever the frequency is, I suppose. So every frequency is a sort of an oscillation of an AC wave, or if it's a direct current, it's sort of not so much frequency, but just probably pulse rate or whatever. I don't know how DC works exactly, but in terms of thinking that way, like frequency wise, it's not really an alternating wave, or I suppose it is in a way. It just alternates very, very gently, not so much so big, It looks more direct, like a straight from one end to the other. AC, they say, sort of alternates back and forth. It's kind of alternating between positive and negative, not so much the start and the end, but more positive and negative. So it's sort of traveling through the line like a spiral, like that, as it gets further and further and further down the line. So it looks like on the thing like that, but really it's doing that, like a pulse. But what I just want to explain was how I explained to my nephew on my family chat how it's sort of like voltage and current. How do I say it? The voltage is sort of the width of the line. So voltage is like how much sort of work the beavers are doing to dig the hole, the tunnel. So the beavers are doing this work to dig a tunnel. They're building quite a big tunnel. That's kind of the voltage. And the current is kind of like all the diamonds they're sending back. So they're sending diamonds back that way while they're digging this way. So it looks like the line's going this way, but everything you're getting out of it's going back the other way. So current sort of goes back that way, while the voltage sort of goes that way. So they're sending the diamonds back out the hole, back to where they started all the time. And that voltage times current is in the way how much you're profiting, how much you're sort of working, the work sort of done, the wattage or the power. So it's kind of like that. You're tunneling and sort of sending back goods that you're finding along the way, and at the end you profit for how much work you've done times how much product you've made. So the current is like your product, and the voltage is like how far you've tunneled, and the width of the tunnel and how big it is, and sort of the wattage is the money at the end, I suppose. That's how I sort of imagine it, because we get confused as to why current behaves in a reverse way than voltage, you know. So that's how I sort of explain it. But in terms of electrical force and electrons and passing on sort of how switches work, where you'll charge a certain chemical, and then when it gets to a certain level, it will charge the next bit of chemical to switch on a switch, you know, once it's up to 3.3 volts or whatever's rating the switch is. So it has, I can't remember the names of the chemicals, like a transistor will have NPN or PNP. They have different chemicals. I can't remember what N and P stands for right now, but you look it up. MOSFETs or something. I can't think right now. I'm just sort of learning all these words and terms and things. But really, what's happening in the line when you look at it, this isn't so much mathematical. This is more the reality of what's really there, beyond mathematics, beyond the realms of possibility, more the realms of impossibility, is that when you have a battery, and then you have a circuit with components on it, going back to the negative end of the battery, the battery's positive and negative terminals, when you switch it on, are connected. So, as we all know, when you get a bit of wiring across the battery, it'll spark and the current will explode the wire, and it'll fuse and blow up the wire and discharge the battery. Because what you're doing is you're connecting one side of the chemical to the other side, which creates a reaction. So without that, there's no reaction because they're not connected. They're just, you know, kept separate in the battery. Some kind of acid reaction in the battery. That's why batteries burn out, because they're burning sort of acid, and after a while that acid can leak out if that connection is left connected. Even if the switches are off, sometimes you get a bit of charge through and it will just slowly burn out the battery. Just trickling away, you're burning it out slowly, you know. So it's best to remove your batteries from your things, especially like remotes which switch on when you touch the batteries. So if you have it stored and something's tapping on the buttons, it will slowly just overwork it and melt out your batteries and destroy your circuits. But back to what electricity is so how does that work? How does that reaction work? So you'll have at one end of the battery positively charged electrons, at the other end of the battery negatively charged electrons. So you can positively charge electrons. They're supposed to be negative, but you can charge them positively and have a positron atom, you know, which you can create yourself by certain chemical mixtures. And it's kind of like you attract so many positive electrons to the atom that it cancels out the negative ones, so you end up with a purely positively charged atom, and that almost has the desire for you. It sort of almost moves our hands in a way. We see something, we want to switch it on. It's almost the desire within that atom to connect to a negative. You know, it's almost like the desire we have as a man to connect to a woman, or whatever gender you are, you connect with your friend or your partner. You know, desire to be with them, desire to spend time. You know, we all want to connect and make electricity. I mean, all of us really. Some people want to connect to God, and you know, some people do evil, and sort of the world wants to disconnect them, so they zaps them out. You know, when they're doing so many bad things. You know, but so when this positive atom is desiring this negative one, and someone flicks a switch, a little message is sent from the end of the battery to the first atom of the wire, the very first one, and it says, Well, the atoms in the wire will be neutral. They won't have any charge. They'll just be neutral, and a bit like a magnet, I suppose, has the same sort of thing. One end of the magnet's positive, one's negative, and the atom will sort of send a message to that first atom in the wire. It happens so quick, you can't time it. It's so fast, and it'll say, "Can I swap spots with you? Because I want to get around to this negative one." So it'll say no, because it's physical matter, right? So that charge from that battery, the charge will swap spots. The battery will take the negative, or not the negative, but the neutral from the wire and change that atom in the wire with a positive. So that's like the voltage tunneling a bit, sort of like that's the first tunneling effect. And then what it does, sending back the neutral, that's like sending back the current. So the neutral's like 0. There's nothing there. The voltage is like 12 volts. And at that time, the amps is 0. The first atom is 0. Then it gets to the next atom, and it will say that atom will be charged positively now in the wire, and it will say, "Can I swap spots with you? I want to get round here." It'll say no, so it'll send the charge to that one. The neutral charge will go back, and the positive charge will move to the next atom. This keeps happening. It's asking all the time, "Can I swap? Can I be you?" They're saying no, so it sends a charge, and it sends the neutral value, which is like diamonds, back. But what happens, right, each time, to create a bit of power, and the power doesn't happen until the whole circuit's complete. That's when the power switches on. That's why it's sometimes a bit of a, when you flick a switch, there's a bit of, or even on a computer screen, you'll click something, and sometimes be a bit of a delay. Some people call it a ping, or the time it takes for a message to get sent. So that first atom that gets the message has to travel all the way through your wire. That's why longer the wire, longer it takes. All the way back around to the negative one before any power is sent. So it's almost like you've got to tunnel your whole tunnel, send back all your current, all your diamonds before you get paid. It's like you've got to do a complete route of that one atom that's sending that charge. So in that, each time an atom sends a charge, a slight bit of that charge gets burnt out or lessened a little bit. Very minute, tiny little bit. So the initial charge is a full 12 volt. Bang, whatever that is, how many atoms has gone. There's not just one goes, a whole lot in that wire is, however thick the wire is. That's why the thicker the wire will send a bigger volt. Some wires too thin, it will burn out. So it's sent, a front of these positively charged charges. A neutral charge has gone back to the battery, and the diamonds, well, as the voltage drops a little bit on the wire, slightly, till it gets to the resistor, a slight bit of ampage goes back. So it's sort of finding a bit more diamond, a little bit of neutral. Instead of neutral, it sends a little bit of positive drops. Oh, I can't think if it's positive back or negative back. Positive, hang on. Neutral goes back. Positive goes forward, slightly less. We'll say 11.9 volts goes forward on a neutral one. And the amps going back will slightly go up, I think, because the power stays the same. The same amount of power. So the voltage goes down to keep the power the same. The amps will go up a little bit. So it sends a little bit of ampage positivity back. So that little bit of positivity that's lost think travels back as positive or negative. Can't get my head around it, but one of you scientists will work it out. So anyway, so it's not really neutral going back anymore. Each time an atom does a bit of work and digs a bit of tunnel, it's finding a bit more amps each time. So by the time it gets past that bit of wire up to the resistor, it might be 11.8 volts. And then it might hit the resistor, which is thick. It has a lot of resistance. It's like a big thick wire made out of, some kind of semiconductor, or so it'll drop the voltage down to like 7 volts through there, and the amps stay about the same. So the amps through there don't really change, but because the voltage has dropped so much, but it's through a thicker material. So I'm not going to do all the explaining, but you work out the amps build up to a certain level to that point at the wire, up to a certain level at that resistor, and then on the other side of the resistor won't be much different because the voltage has dropped so much. So the compensation, all that, the amps coming back until it gets to that next bit of wire will be about the same. So by the time it gets to that wire and that resistor, it's probably about the right amps. It's about, it's up to 3 amps or something, or 3 milliamps or something, some small amount. So that's how it works going around. It's sort of sending a charge, getting a response, sending the charge on again, getting another response, and it slowly sort of, the voltage moves forward by atom as the current goes back to the battery. So, and then by the time it gets all the way around, the voltage completes the circuit, and then the current going back the other way completes the circuit, negative to positive. But in a way, it's positive to negative because it's the opposite. The current's kind of opposite, kind of negative, positive. Voltage is positive and negative, so it goes the other way. So, yeah, you'll get readings that sort of tell you the opposite. The circuit's operating is just because you're reading the current, not the voltage. And that's how it works in a series circuit when everything's connected in a line, So that's the best I can explain. So really that 12 volts will get all the way around the other side. By the time it does, it's basically used up that 12 volts by the time it gets to the very end, and then it'll send a signal back to the positive end of the battery that the current's full, but the voltage is empty. So it's saying the work's done. We've got everything. We've got all the diamonds. We've finished our work. We can all relax, till the next frequency wave or whatever, direct current pulse or whatever. So a pulse is like just an atom moving, I suppose. I suppose it can be atomic, or you can measure it however you like. Some kind of. You can probably look up how DC is measured. In kind of frequency way, it might be micro frequency or something. Not so much hertz, but maybe nanohertz or something. I'm not sure exactly how it works, but I think it might be just a very slight buzz, whereas an AC is more like this. Direct current's like bzzz, very, electricity looks like it's buzzing a bit. It's probably more like that. So yeah, that's how it sort of works. And same with lightning, There's a positively charged sky, and then the Earth is sort of neutral. And maybe there's a negative charge somewhere. It's going to look for a negative charge anywhere, a negatively charged atom to connect to, and then sort of branch out and sort of find all the other ones. There's little ones everywhere. And it'll follow a path, a neutral path, sort of like through the sky, or is all neutral, or even a lot of your body's neutral, There's a lot of neutral atoms. It'll look for neutral ones to sort of send back, to create a current. Because it's easier pushing current back from a neutral atom. That's why things are conductive. Whereas say plastic, you try and put a current through that, it won't even get a message because there won't be any response. You know, it'll say no, but then it won't pass on a charge because there's no way of sending that back. You know, the material doesn't pass the charge on. So that's the difference between things that conduct and things don't. So the structure of the atoms and how they pass on messages and things. But a big enough charge would, you charge it up enough, it would send enough current to change that atom into a neutral to send back and then create a current and then send that message back to wherever the voltage source is, the ground, or to complete the loop, So I hope you got something out of that anyway. A bit mysterious how, but yeah, there's definitely something to start with, some chemical reaction that sends that some question or some motive, or they're called an electromotive force of 12 volts or the 240 or whatever you're using, to send that message initially to get the motion happening. It's when you flick on the switch and connect those initial atomic messages that pass on. There's something underlying that which says we have a pathway. There's a promise we can make it back around, and it's saying, where's this? It's saying, can I get around to this negative? I'm attracted to this negative. I can't go this way. Can I go back around? So that's how it works.